Hello. In section 2.3, we're going to be talking about association and correlation. So they are very important: correlation, association, and covariance. So first thing we can do is look at the correlation. As we have discussed this before, df.core will actually give us the correlation matrix. As you can see, that is going to be a square matrix of all of the fields that you have, numerical fields that you have in your original data frame. So correlation is going to range from -1 to 1, and then we can actually convert this into a heat map for visualization purpose. You can see that in diagonal, because it's a correlation to its own, it's always going to be 1. However, we do see some darker places like here and here to tell you that these are the highly correlated features. Estimate value to number of bathrooms definitely has very high correlation. So now, what is the difference between covariance and correlation? Covariance is the unstandardized form of correlation. So correlation is derived from covariance. You will get the covariance first and then standardize it so that it becomes from -1 to 1. However, covariance can be anything, but it captures the variance of the relationship between the variance of one features and another features. So you can see that this is my covariance matrix. It can be anything. It doesn't have to be from -1 to 1. This number is very big, right? You can actually see it's like it has like 7 zeros. So definitely looking at this to determine which features to use, I will typically look at df.core, look at the correlation, and then right now my predictive, my target variable is estimate value in this data set. Therefore, I want to look in this column, the last column, and pick the ones that have the highest correlations. For instance, the number of bathrooms, square footage, prior sale amount. All these are good features. So that's when we want to look at correlations and covariance. And also the other one is detecting outliers. So when we're trying to look at a new data set, we want to have a good understanding of what the outliers are. So remember we talked about the linear regression model in a previous video, which can be distorted by few outliers, because we're trying to fit a line into a data set, into a given data set. And then if we do have few outliers that are far away from the majority of the data points, then it is likely that this line that we're trying to fit gets lifted or by these few outliers. That's why you need to be careful, and then you want to either drop them, remove these outliers, or impute them using your average, median, right? So first of all, let's take a look at how we can determine the outliers, how we can detect the outliers, how we can remove them. So remember, X is what we have used as our feature matrix. So we have all these 7 features, and what we're trying to predict is Y, right? Is our estimated value. So we can actually reassign this. Okay, so Y now is going to be our the estimated value of a property. So now let's look at the columns, right? We have, this is a good function, a very convenient function. You just do df or x.columns, and you get all the columns. For all of the column header, so I want to loop it through to get the histogram, right? So that's what I'm actually doing. And then also print out the mean and then standard deviation, right? And then really show the histogram. So as you can see, right, starting from the top, so the number of, this is bedroom, is centered around 3, right? And then it has some like normal shape. So what I can see is if it's above 6 or 7 or 6 or 7, that's where I can draw the line, right? And say that's outlier, right? So from this just purely look at the histogram, I can actually do that. And also, if it's 0, yeah, it's unlikely that you can have a 0. Well, bedroom, you can have 0 bedroom. It can be a studio, right? So, and also bathroom. So you have some 0 bathroom, which is weird. It could be because we filled it with the null values with zeros. So we need to definitely be looking into this. And then yeah, the same thing. Whenever it's like over 6 or 7, I can see that it's an outlier, right? And then number of rooms, something like 15, right, is where I can draw the line and say, yep, that's an outlier. And then and so on and so on, right? So it's a lot of time it is visual inspection. You can definitely look at the histogram and look at following the 3 sigma rules, right, to really detect the outlier. So 3 sigma rule is where you can look at the histogram and determine where you should draw the line, right? And then, for instance, how would you then slice or remove the outliers? Remember, how you can do that is by taking, say, x dot bedrooms will give you the entire column. And then you can say you only want to include whenever x dot bedroom is less than 7. So that's how we draw the line. And then you want to then assign this, right, back to another as x2, right? So now if you look at x2 dot bedroom, bedrooms dot histogram, then yes, so there is no data point that's above 7. Okay, so therefore you can actually see this is how you can remove or drop your outliers, right, easily. And then what if you want to drop 2 things, right? So you want to say, I want to remove anything that is going to be say bathrooms, right, is going to have more than 7 bathrooms. So I consider that as outlier, and then you can drop having 2 conditions and then join them with and then assign that to 2. So now if you look at bathrooms with the new variable that you just assigned, x2, you can see that is all less than 7, or even the maximum is 6, right? So this is how you can drop, and you can have many conditions, right? Condition 1, 2, 3, 4, and then sequence them and combine them all together. So this is one way, very quick way of removing some outliers. And then another way is really a box plot, right? So Seaborn has really easy box plot. What if I want to say, look at just x? So this will tell me for every feature, right, what is the box plot. But because the prior sale amount is has a different scale, right? So it's actually really not easy to read. So what I will do is I will just not include that, right? I will split this into 2 box plot. I can just copy from the columns, right? So that's easy for me to not to type it. So I can say, so I only want to look at the box plot for these columns, right, in my feature matrix, right? Okay, this is how you can slice a data frame. Remember, 2 square parentheses. And now let's look at the box plot, right? So lot size is still kind of like skewing the results, where it's not really giving us a good view. So I'll just remove it and look at it again. Okay, wait, what did I do? So by going back, it's Command Z, right? So lot size and square footage, I think it's both. Both of them are too big. Year built as well, yeah, I should include it. So let's just say bedrooms, bathrooms, and rooms, right? You can actually see, yeah, definitely these are outliers, right? Whenever it's like above 25, definitely in terms of, in rooms, then I want to consider as outliers. But typically, people do is they will use, somewhere that's from 25 percentile to 75 fifth percentile. So you only want to include the data points that belong to that range, right? Like 25th percentile to 75th percentile. But you can be more flexible, right, on how to pick that cutoff. But I will say, in looking at this, for bedrooms, I think, what we have picked before, 7 is a good cutoff, right? 7, and then bathroom is, I think 7 is a good cutoff as well. And then for rooms, I will say 20, that's kind of like a good cutoff. So then we can go ahead and remove all of that. So, and then let's look at, square footage, the other features that we didn't include, right, in our box plot initially. So in here is the square footage and lot size. So that's the name of the field. And then let's look at these two together. So yeah, definitely it has many outliers in here. So anything that's above 50,000, I will say, yeah, it's outlier. So let's just look at the square footage first. I will say square footage 4,000, that's where I can draw the line. And then what if I want to look at the lot size alone, right? And then, yeah, definitely I can see it's anywhere, that's about 40,000. It's a good cutoff. So I want to then remove the data points that reside in this area that are, in here, and then treat them as outliers, right? So you can actually play with this, one by one, look at it, or you can have a combined view, right, of more than one variables and really to test which one you should, where you should draw the line, right? You can look at different permutations of features to determine that. But today, I think we're just gonna, use box plot as well as 3 sigma rules, these two as the primary ways to detect outliers, and we can remove the outliers, right, so that our models won't get affected by these outliers. And a good way of looking at this is if you do have many outliers, it could be just that you need to reposition your problem into outlier or anomaly detection. So you're going to have perhaps 2 models. One is the model that you're going to be using for your major data points or major scenarios, and the other is for outliers. So you can have 2 models, and each will have its own purpose, right? So that might be a good example as well. So that's it for 2.3. And then in the next section, we're going to talk about dimensionality reduction.